Good morning, all students. Your exercise number 4 is implementation of regression model. Under this topic, you'll be doing the implementation of linear regression, multiple regression, and polynomial regression. For today's topic, I'm going to teach you how do we do the implementation of simple linear regression. So before we go on to the practical implementation of linear regression, we will know what is the explanation for the linear regression model. So regression, it's a common statistical method that is used in businesses. Say for any of the business, if they want to increase the profit, so they should know that what are all the various parameters they need to focus on. So, be it an educational institution, say for example, if you would like to calculate, know what is the CGP of the marks or the percentile of the marks that will be secured by the student based upon so many performance, based upon the different features, such as how many number of hours he has spent in studying, how many number of hours he has spent in practical coding. So this is a kind of statistical method that is used in business, and this is a tool that also helps to pool the data together, and that help the people and companies to make some informed decision. Say for example, if there is an industry which is running or which is going in a loss, so they should know that what are all the parameters they need to focus on. And say, for example, if they would like to predict the future economic condition or trends or the values, say, for example, how the sales of the product will be there during the seasonal period. So, in all these, we see that the regression model in machine learning plays a key role. So, this regression model, it also helps to assess the kind of the relationship between two or more variable. Okay, so generally we call it as dependent variable and independent variable. And this is a kind of model that helps to understand how the change in one variable will have an impact on the change in another variable. Okay, so say for example, if there is an increase in the number of hours that is spent by the student in studying, obviously there will be an increase in the percentage of the marks that will be secured by the student. So these are all some of the important features of regression. And what are all the uses of the regression analysis generally? It is used in the predictive analytics. Say for example, what would be the number of items a customer would buy? Okay, so in a near future. So, in this type of regression, okay, so we see that the input also will be a numerical type of data, and output also it will be a numerical value. Okay, and secondly, it helps to improve the operational efficiency of the business. Okay, so where they want to increase, say for example, if you'd like to determine what will be the profit of the organization, considering various parameters such as how much do they spend in the research and development, how much do they spend in advertising and marketing. So if there is an increase in the amount, what do they spend in R&D and advertising and marketing? And obviously, there will be an increase in the profit of the organization. So that helps the organization to improve the business efficiency. And this also supports the management in taking any of the decision. Okay, so say for example, if they if there are so many employees who are working in an organization, so if you would like to assess, okay, so how the increase in the salary have to be given based upon the performance of the particular employee. And this also helps the people and the business professionals to correct the errors. So, and hence to provide a quantitative support. So, what do you mean by this correcting the errors is like, say, for example, whether all the employees are paid correctly. Okay, so according to the years of experience. So, in case if there is any such issues, okay, this is a type of a model that will help them to rectify, and this also helps to get a new insight based upon the increase in the demand. Okay, so in the market on a weekly basis or sometimes on quarterly basis or based upon half yearly basis or on yearly basis. Okay, so the simple linear regression, okay, so we see that this comes under supervised model. So you all know that supervised model, it's a model in which you have your input features with labeled output responses. And this model the relationship between a dependent variable and independent variable. So when we take into consideration of regression, there are different categories of regression. Okay, so we have simple linear regression, we have multiple regression. Okay, so one such is simple linear regression. Okay, so simple linear regression, it helps to model or assess the relationship between one independent variable and one dependent variable. Okay, so there will be only one independent variable and one dependent variable. So this dependent variable can also be called as response variable, or sometimes you can call it as the target what you want to predict. An independent variable, okay, or those that is called as features for simplicity. So when you are able to predict a response using one single feature, then that is called as simple linear regression. Then that is called as simple linear regression. So generally, when we assess the kind of relationship between the dependent variable and the independent variable, so there are three different categories of relationship that is called as positive correlation, negative correlation, and no correlation. So positive, whenever there is an increase in the input variable, there will be an proportional increase in the output variable. So in the case of the negative correlation, okay, so when there is an increase in the input variable, there will be a decrease in the output variable. And in the case of the third type of correlation, that is called as no correlation. So how much ever we either increase or decrease the input variable, there will not be any change in the output variable. Okay, so this is being represented by the diagrammatic representation, how it is given below. So, say to give the explanation, we'll take a simple sample data set. As I have told that this is a kind of a model that helps to model the relationship between one independent variable and one dependent variable. So, in this example, the independent variable, what you are going to consider it is the years of experience, and the dependent variable, it is the salary. Okay, so normally we will try to calculate the salary based upon the total number of years of experience. Okay, so we calculate the amount of salary that is earned by an employee based upon the number of years of experience. So this is being represented with a mathematical representation. Okay, because the case of linear regression, you already would have studied. Okay, so you make use of a best fit line in order to plot or to fit all the data points. So mathematically, okay, so if it is going to be a straight line and which is of a kind of a slope, then that have to be represented by the slope equation. Okay, so how do we represent y is equal to mx plus c? The same is represented here, y is equal to b naught plus b1 into x1. Okay, so where x1 is the independent variable, b1 is the coefficient. Okay, so that is how much is the rate of change that is being created, and b naught is the constant and y is the dependent variable. So with the given input data set, this is the plotting. Okay, so where x-axis is it represents the years of experience, and y-axis it represents the salary that is earned by the employee, which is just a simple scatter plotter. So whatever the input data points that is being shown in a kind of a 2D graph. So here we see that the same mathematical representation. Okay, so how do we do the calculation of the values of B and C? Okay, so say for example, B is a value. This is your input data set. Okay, so we'll post this data set. And this is a graph that represents the x-axis is the years of experience, y-axis is the salary, and here is the best fit line, and here all the data points that is being plotted. So here the value for B, how do we calculate the value for B is the slope. Okay, so mathematically B is calculated using the formula B is equal to y2 minus y1 divided by x2 minus x1. Okay, so this you would have studied even in your mathematics, what you had studied in your school days. Okay, so that is the difference in the change of the variable. So say for example, if you consider x1 as 1 years of experience and x2 as 5 years of experience, y1 as 3 and y2 as 6. So b is calculated as b is equal to 6 minus 3 divided by the value as 5 minus 1, okay, which is equal to 3 divided by 4, and that gives the value as 0.75. And how do we calculate the value of c? C is a constant. Okay, so when can you will get the value of C? Okay, so provided when this term, that is B into X, when this term becomes 0, so we'll be able to know what is the value for C. So when this term can become 0, only when the X, that is the input years of experience, is 0, that is at the origin. Okay, so only at when x is equal to 0, it represents the person with 0 years of experience, who is a fresher. Okay, so at that time, what is the salary that is earned by the person? Okay, so here we see that at x is equal to 0, we see that the person, he earns the salary of 20,000 rupees. So this is just the description. Okay, so how do we need to? So what is the task for us? Okay, so the task for us is to find a line that will better fit all the scatter points that what we have seen. Okay, so that we'll be able to do the prediction for any of the new value what we give as an input. So this line is called as the regression line. Okay, so and this line can be obtained using a method, this mathematical method that is called as ordinary least mean square method. This method is called as ordinary least mean square method. Okay, so here you can see that the same is being represented. Okay, so this is a simple linear regression. Okay, so when the person has joined freshly and he has earned the salary of 30K dollars, and x-axis it represents the experience and y-axis is the salary. The same when you give it in the form of an equation, y is equal to b naught plus b1 into x. So what does x it represents? X it represents the input variable. Okay, so or you can call it as an independent variable, that is the number of years of experience. And what is y? Y, it is the salary that is earned by the person. Okay, so and this is like the how do you assess? Okay, so say for example, let us imagine this is going to be the best fit line that you acquire. Okay, so that has better able to fit all the data point. Okay, so you would like to know what should be the increase in the salary or the increment that have to be given for the person with 1 year of experience. So how this could be done? Okay, so for this best fit line, it gives us a better help. Okay, so you can see that, say for example, okay, this is going to be the person with 4 years of experience. Let us imagine this point, it represents the person with 5 years of experience. So the difference between 4 and 5, it is just 1 year. Okay, so and after 1 year of experience, how much the increase in the salary? So to understand that, okay, so you can project this line towards the best fit line, and this line also towards the best fit line, and then project it towards the y-axis. Okay, so and when you are able to find out after projecting over the y-axis, you'll be able to exactly know what is the difference in the value. Okay, so it is going to be like nearly 10k dollars should be the increase in the salary for the person with 1 year of experience. Okay, so we see that how this is all able to give us such an excellent support for us people. Okay, so for the management, for any of the person, okay, so who would like to take prior decision, okay, so correct decision. So we see that, as I have told, that the error rate can be calculated with the help of this model. Okay, that is the mathematical technique called as ordinary least mean square. Okay, so how this can be done by calculating the difference between the modeled value, or you can call it as predicted value, and the actual value. Okay, so say for example, this all those red data points, okay, that represents the actual value. Okay, and this predicted value, this mathematical prediction, the best fit line is given by this straight line. Okay, so that is represented by the variable called as y cap. Okay, so by taking the average of all the value, by taking the average of all the value of the difference between the modeled value, the actual value, and the model value. Okay, so by taking the average of all the value, so for what particular line, if you are able to get the minimal error rate, that will be chosen as the best fit line. Okay, so so many random projection. So this is where we see that the person with 0 years of experience. Okay, so so many random projections of line will be drawn, and the line which is able to better cover all the data point accurately will be chosen as the best fit line. So this can be represented, what is the minimum of the error rate? Minimum is the difference between the modeled value and the actual value and the model value. Okay, so this is again given here, the formula error is equal to actual minus predicted value, and actual is represented by yi, predicted is represented by yi cap. So the sum of squared error is equal to summation of I is equal to 0 to n, that is yi minus yi cap the whole square. Okay, so the minimum of the error, that is sum of squared error, should be minimum. Okay, so with that, we are going to stop with the in the explanation for the simple linear regression. The next is we will learn practically how already you would have done this in a few other labs. So we are going to explore it, how we are going to do the implementation of the simple linear regression. Thank you all.